Hello students, welcome to Sreenath. In this video, we are going to discuss the 6th class CBSE mathematics subject. In that subject, chapter 2, which is whole numbers. Okay, my name is Karthik Nune. We are creating all videos on all subjects from class 6 to class 8 CBSE. So please subscribe our channel. Also like and share our videos. Let's begin this chapter. Okay, so now what is the chapter name? The chapter name is whole numbers. Okay, in this chapter we are basically having 5 topics. Okay, 5 topics, 5 concepts. So if you clearly learn these concepts, then you can do the problems in the exercises. So in this video we are only discussing the concepts only. We are not discussing the problems in the exercises. So you have to understand these concepts and do the exercises by your own. If you want the problems on the exercises will be solved by us, please comment below. Then we will upload the videos on exercises. Okay. So now we are going to have an overview of all the whole chapter. So basically in this chapter we are having 5 topics, 5 concepts. The first topic is about the introduction. So basically in the introduction what we are going to learn, about the predecessor and successor, which we have learned in the previous sessions. And the next topic is the whole numbers. So this is the whole chapter name. So what are whole numbers? We are going to discuss about those. And next topic is the number line. So what is the number line and how we will represent the whole numbers on number line? Okay, and how we will addition on number line, subtraction on number line, multiplication on number line. Okay, all those topics, we will discuss under the third topic. Now we are entering into the fourth topic. The fourth topic is properties of whole numbers. So what are the properties of whole numbers? Basically there are closure property and some other properties like associative property, commutative property, like that. So we are going to discuss all those properties. Okay, distributive of multiplication or addition, it is also one of the property. So like that we are going to discuss all the properties in the fourth topic. Now it is the time for fifth topic, which is patterns in whole numbers. What are the patterns in whole numbers? How we can use those patterns to simplify our calculations. So that is the whole chapter and the pattern observations, like that is the whole chapter we are going to discuss. Okay, that's it. Our chapter ends here. So this is the whole chapter. We have completed the overview of whole chapter. What are there in the whole chapter? Now what we are doing, now we are entering into the deep discussion session. Now we will discuss each topic in detail. Basically the first topic is introduction. In introduction, what we are going to learn, basically what we have learned in our previous classes or in previous sessions, we are going to repeat or revise those topics. So basically in the previous session, what we know about natural numbers. So what are natural numbers? We will represent natural numbers by n, and the set of natural numbers are they are starting from 1, 2, 3 and so on, they goes on. Okay, basically natural numbers are represented by n and they starts from 1. Now what is meant by predecessor and successor? Suppose if you take any natural number, suppose 3, if you add 1 to it, you will get the 1. So this 4 is called the successor of this number. So this 4 is called the successor of this number. Then what is a predecessor? If you take the same number, that is 3, and subtract 1 from it, then you will get the 3 minus 1 is the 2. So 2 is called the predecessor of this number. So 2 is called the predecessor of 3. Okay, this is the 4 and so on. So this is the number we have taken. The predecessor of this 3 is 2 and the successor of this 3 is 4. When in the case of when we were representing the natural numbers on number line, the successor is always on the right side to the number, and the predecessor is always on the left side to the particular number. Okay, this is all about the successor and predecessor. Only one thing we have to remember is, if you want the successor of any number, just add 1. That's it. If you want the predecessor of any number, just subtract 1. That's it. Then you will get the predecessor of that number. Okay, when you add 16, the successor of 16 is 14. Why? Because means 16 is added to 1, then you will get 17. The successor of 19 is 20. Why? Because means you have added the 1 to the 90. That's it. And the successor and the predecessor of 17 is 16. Why? Because we have subtracted it with 1. And the successor and the predecessor of 20 is 19. Why? Because means we have subtracted it with 1. So this is about the successor and predecessor. Okay. So, and we have discussed, revised about the natural numbers and the predecessor and the successor. So first topic is completed, which means introduction is completed. Now we are entering into the whole real chapter, exact chapter. That is the second topic here. The second topic is the whole numbers. So what are whole numbers? Whole number. So whole numbers are nothing but basically natural numbers. Natural numbers represented by capital N, and whole numbers, we represent whole numbers by capital W. And these natural numbers, okay, these natural numbers are started from 1, 2, 3 and so on. These whole numbers are starting from 0, 1, 2, 3 and so on and so on. So what are whole numbers? Whole numbers are nothing but the numbers starting from 0, 0. If you add 0 to natural numbers, then you will get whole numbers. So whole numbers are nothing but when you add 0 to natural numbers. Adding means not addition, but just a combination of natural numbers and the 0 together. That set is called whole numbers. Okay. Whole numbers. Okay. Now I think you have able to understand what are whole numbers. So how we will represent the whole numbers? Whole numbers is equal to set of 0, 1, 2, 3, 4, 5, 6 and so on. They will go on. So this is about the whole numbers. Whole numbers starting from 0. Okay. That is, suppose if you have a bag, in that bag there are numbers 1, 2, 3, 4 like that. So all these are natural numbers. This is the bag of natural numbers. So in that bag you have dropped one number, that is 0. Then what happens? 0 will come and sit here. Now this bag becomes W, which means whole numbers. Previously it is natural numbers. Why? Because in that case there is no 0, but when 0 is added to the bag of natural numbers, then it becomes the whole numbers. So whole numbers is the combination of 0, 1, 2, 3, 4 and so on. Okay, that's it students. That is about the whole numbers. Basically, what is the difference between natural numbers, whole numbers? Only difference is whole numbers contains 0. That is the extra thing, ante. That's it. So we have completed the second topic also students. Now we are going to discuss the third topic. So what is the third topic? The third topic is the number line. What it is? Number line. So what is the number line? Basically we have discussed number line in natural numbers. Now we are going to discuss about the whole numbers number line. How we will represent the whole numbers in number line. So basically for that purpose, take all the whole numbers, that is 0, 1, 2, 3, 4 like that. And what you have to do, you have to start the number line. We have to start the line at 0. It is the starting point, and you have to draw that line towards the right like that. And the distance between every whole number is equal. The distance must be between every whole number must be equal, and the distance between every whole number is unit distance. That is unit distance. Okay, simply in other words, starting from 0, taking unit distance, mark whole numbers. We have started here and taken the unit distance, and you have marked 1 here. This is the first whole number. This is the 1. Next, you have again taken the 1, you traveled the 1 unit distance, and again you named it as the second whole number. There is the whole number, that is 2. And next you have taken another unit distance, and you have written the 3 like that. This number line goes on like that. So this is the number line. In this way we are representing the whole numbers on the number line. Okay, this is about the number line. Now if you clearly see this number line, if you want to take 2, then if you take 2 and find its successor and predecessor. The successor of 2 is 2 plus 1, that is equal to 3. The predecessor of 2 is 2 minus 1, that is 1. If you observe 2, 3 and 3 on the 3 and 1 on the number line, where there are, this is the 3 and this is the 1. So these are in between the main number. Our taken number is 2, is the whole number. Basically the successor The successor of this 2 is on the right side in the number line, and the predecessor of the 2 is on the left side on the number line. Okay, so if you take any number and you have add that predecessor will be on the left side and the successor will be on the right side, students. Now we are going to discuss how to add additional number line, how we will add on number line. Basically this is the number line. So if you want to add anything, suppose if you want to add 3 plus 4, so we have to add 4 to 3. What you have to do, you have to see the number 3 on the number line. So this is the number, and what you have to do, you have to make 4 steps. How many steps? 4 steps are 4 jumps, and each jump is step length of 1 unit. So you started here and you are doing 4 jumps. So first jump, second jump, third jump, fourth jump, and what the condition is, the step length is 1 unit. So for this is the 1 unit, the difference between this is the 1 unit. Okay, 1 unit, first jump, second unit, second jump, third jump, fourth jump. So what is the number you get? That is the 7. So basically if you add 3 plus 2, you will get 7. So in this way you will get addition on number line. Okay, students. Then how subtraction on number line? For that, suppose if you subtract 7 minus 5, what you have to take, you have to locate the position of 7 where it is 7, and what you have to take, you have to move left, you have to subtract 5, which means you have to move left, and you have to make 5 jumps or 5 steps. You have to make 5 steps or jumps on left side in the case of subtraction. And in the case of addition, you have to make if it is 4, so make 4 steps on right side. So locate the 7, it is the 7, and makes 5 steps to the left side. So first step, second step, third step, fourth step, fifth step. After fifth step, you will get the number at 2. So 7 minus 5 is equal to 2. This is the actual subtraction. Okay, in this way, while addition, you will move right on the number line. In the case of subtraction, you will move left on the number line. And one thing is, in both these conditions, step size is, or step length is 1 unit only. This is the primary condition. And now what is the multiplication on number line? How multiplication will be done on number line? So basically, if you want to multiply 4 into 3, which means what? 4 means we have to take 4 jumps. What is 4 jumps are 4 steps. And what is the 3? 3 represents the step length. Here the step length is 3 units. So in every jump, every jump must have 3 units step length. So if you are doing 1 jump, means you are moving 3 units on the number line. So like that, you have to move 4 jumps or 4 steps. So first you have to start from origin. And what you have to do, you have to take 4 steps. Each step is having 3 units. So this is the origin. You have to take first jump, that is the first jump. In first jump, you have covered 3 units distance, 1 unit, 2 unit, 3 unit distance. Next, you have to have the second jump. In second jump also, you must have 3 units distance. Next, third jump, and finally fourth jump. So after completing the 4th jumps, you will land on the 12 number. You will land on the number called 12 on number line. So that is the result. So basically, if you multiply 4 into 3, you will get 12. So in this way, you will multiply on the number line. Simply one thing. If you want to multiply any 2 numbers, the first number represents the how many steps you have to taken, and the second number represents the what is the step length. And you have to start from 0. You have to start from 0. But in these cases, you have to start from where the first number is. Suppose it is 3, then you have to start from 3. Suppose it is 7, you have to start from 7. But here you have to start from 0 in the case of multiplication. Okay, students, we have completed the third topic also. Now we have entered into the fourth topic, fourth concept, that is properties. So there are some properties for whole numbers. So what are the properties of whole numbers? First property is the closure property. We are going to discuss this closure property under addition and also under multiplication. Okay, if a whole number satisfies the closure property, then we call that whole numbers are closed under addition, whole numbers are closed under multiplication. That is the statement we are giving at the end. So suppose what you have to do, take two whole numbers 7 plus 8 and multiply or add those numbers, you will get 15, which is a whole number. Now add another two whole numbers, in this also you will getting 10, 5 plus 5 10, it is also whole number. So these two are the whole numbers. By adding two whole numbers, you are again getting a whole number. So we called it we called this as the whole numbers are closed under addition. Whole numbers are closed. Closed means they are satisfying the closure property. Whole numbers are having the closure property. Closed under here. What is the operation? The operation is addition. So if you take two numbers and add two numbers, you are again getting the whole numbers. Then we called as the whole numbers are closed under addition. So if you take any whole number, any two whole numbers, and try to add any two whole numbers, then finally you will get, always in every case you are getting the whole number only. There are no two whole numbers. When the two whole numbers are added, you are getting a non-whole number. It is highly impossible. There are no such numbers, no such whole numbers. When we added them, we will get no other than a whole number. It is highly impossible. If possible, please comment it below. Is there any numbers where by adding those two whole numbers you are getting non-whole number? Then please comment below. Okay, that is about the whole numbers are closed under addition. Now what you have to do, this is about addition. Now again take another two whole numbers or same two numbers and multiply both whole numbers. Again you are getting some result. 7 into 8 gives rise to 15. And again 5 into 5, 5 into 5. Now you are multiplying both numbers, you are getting 25. If you consider these two are also whole numbers, so we have taken two whole numbers and you have multiplied those two whole numbers, you are getting a new number, new result, new answer, that is also whole number. So if you go on research and if you do all the multiplications of all the whole numbers, you will find that every time the result is a whole number. Every time the result is a whole number. So that's why whenever two whole numbers are multiplied, if the answer is also whole number, so we call that closure property is satisfied under multiplication. So we say that whole numbers are closed under multiplication also. Under multiplication also they are satisfying the closure property. So finally, what is the closure property? Whole numbers are closed. Here what is the conclusion is, whole numbers are closed under addition and also under multiplication. Under addition and multiplication also they are closed, which means they satisfy the closure property. Okay. Now if you try with subtraction, then whenever you subtract 7 minus 8, it will give some value which is not a whole number. So subtraction is not a whole, subtraction is not closed. Subtraction is not closed for whole numbers. Only addition and multiplication is closed for whole numbers. If you take division also, sometimes if you divide 5 with 7, you will get 5 divided by 10, which is also not whole number. So division also not possible, and division also not closed under whole number. Sorry, division is also not closed whole numbers. Okay, basically now if you try to now we are going to, is the division by division by 0 is possible, is division of whole numbers by 0 is possible. Let us try. Normally what is meant by division? If you have to divide 8 divided by 2, what you have to do, we have to subtract 8 every time with 2 until you get the answer 0. So subtracting 8 with 2, you by 2, what you will get? You will get answer 6. Again subtracting, you will get 4. Again subtracting, you will get 2. Again subtracting, you are getting 4. In how many steps you are getting? You are getting in 4 steps. So what is the answer? 8 divided by 2. 8 divided by 2 is equal to 4. That is the answer. In this way, if you start dividing 2 with 0, every time you are subtracting 0, you will get again 2. So the steps goes on under you didn't find anywhere, the answer will be 0. So 2 cannot be divided by 0. So we say 2 is not defined. So divided by 0 is not defined. So finally what we can say, that any whole number can't divide by 0. We can't divide any whole number with 0. That is the conclusion. Division of a whole number by a 0 is not defined. It is not defined. So now we have completed the first property. We are coming into the another property, that is the commutative of addition and multiplication. So what you have to do, if we possible, try to do additions on the number line, or otherwise simply normal addition. So suppose if you add 3 to 2, what is the answer? The answer is 5. And if you add 2 to 3, again in this case also the answer is 5. Suppose here what you are adding 3 to 2, which means you have to start from 3 and have to take 2 steps. So after taking 2 steps, 1 step, 2 step, you are getting into 5. In this case what you are doing, you have started at 2 and you are taking 3 steps, which means first step, second step, third step. At what you are ended at 5. So in both cases the answer is same. So what you have done, first you have added 3 to 2 and you are getting 5, and this case you have added 2 to 3, you are getting 5. So even though you have interchanged the digits, the answer is same. So we call this as the commutative. You can add two whole numbers in any order. So you can add any two whole numbers in any order. So order of the addition is not a problem. So you can add two whole numbers in any problem. So we called it as the commutative property. So addition is commutative for whole numbers. So addition is commutative for whole numbers. This property is called commutativity for addition. This is for addition. This is the commutative property. You can add any whole numbers in any order. Even though you have changed the order, the answer will not be changed. So this is called commutative property. Now coming to multiplication. Now we have multiplied 4 into 5, you will getting 20, and again now we are multiplying 5 into 4. In this case also you are getting 20. So in this case also, in this multiplication also, you have changed the order, but the answer is same. So you can multiply two whole numbers in any order. So in this case also, order does not take constraint. So by changing order, no problem, you can easily, by changing the order, you can easily get the same answer. So this is called commutative. Say multiplication is commutative for whole numbers. So finally what we can conclude, that addition and multiplication are commutative for whole numbers. Previously addition and multiplications are closed for whole numbers. Here addition and multiplication are commutative for whole numbers. That is the closure property. This is the commutative property. Here we have changed the order. We have even though you have changed the order, there is no difference in the addition and multiplication. But subtraction and division are not possible. They are not commutative. When the order is changed, their values will be changed. That is about the second property, commutative property. We have completed it. So we have completed the, what is the property? We have completed the closure property. We have started the second property, that is commutative property. This is also completed. This is also closed under addition and multiplication. Now we are discussing another property, that is associative property. Associativity property. Third property. What is the associative property means here? Now here are the two examples. Now what you are doing here is the example of 2 plus 3 plus 4. Okay, this is the one thing. So in this case what you are doing, you are adding these two numbers in the first step. So 2 plus 3 gives rise to 5, plus remaining thing is 4. So what you are adding, the result of these two numbers is 5, and now we are adding 4 to this result. That will give the answer 9. Now what you are doing, now you have changing the order, not the order. Now you have taken these two numbers at the first time. So 2 plus 3 plus 4. Okay. Now what you have done, you have taken these two numbers at the first time. Now you are adding these two numbers in the first step. So 2 plus 3 plus 4 becomes 7. So now you are adding 2 to this 7. Now it answer becomes 9. So in both cases answer is equal. So what we can conclude that? This is associative of addition for whole numbers. Why? What we called it as? We called it as associative of addition for whole numbers. notice how we grouped the numbers for convenience of adding. So in the beginning we have grouped these two numbers and find out the result. In the second method you have grouped these two numbers and find out the results. In both cases, whatever the grouping you have done, that is not problem for getting answer. So you can group which numbers you want, which numbers you like. So there is no problem in grouping of any numbers, any whole numbers. The answer is same. This is called as the associative property. Thus associate is satisfied under addition. Now we do it for multiplication. So in the same case, here is a game like that. So here in the case of multiplication also try to do this. Okay, basically it is having 3 columns and 2 rows. 3 into 2. How many are there? This is the 1, 2, 3, 4. So finally what is 4 into 3 into 4? Okay, so basically each brick or each box is having 3 rows, 2 columns, and how many boxes are there? There are 4 boxes. So now if you calculate those values, what is the answer? 4 into 3 into 2 means 6, that is equal to 24. Now coming to this, it is having 1, 2, only 2 boxes, or how can we 2 boxes, and each it is having 4 rows into 3 columns. It is also having 4 rows into 3 columns. So 4 rows into 3 columns. We have to group it because one box is containing 4 rows into 3 columns. How many boxes are there? There are 2 boxes are there. So now what you have to do? First you have to multiply this one which is in the brackets. Why? Because means first you have to multiply for one box. For one box 4 into 3, that is equal to 12. And how many boxes are there? There are 2 like boxes. So that is equal to 2. That is equal to 24. So in the both cases you are getting the same answer. Even though if you are grouping these two numbers and these two numbers, even though we have changed the grouping of the numbers, the answer is same in the case of multiplication. So what we can say is associative property, associativity. This is associativity of addition and multiplication for whole numbers. For what? For whole numbers. So this is the associative property. Even the grouping is changed, the result is not changed. So it satisfies the associative property. This property is satisfied under addition and multiplication. Okay. Okay, students. That's it. Now, thus the next property is the distributivity of multiplication over addition. This is the another property. Okay, basically if you try with the division, for the associative property, it will not be same. The answer will not be same in all cases. So division is not associative. Okay. Now we are coming to the fourth property, that is distributivity of multiplication over addition. Suppose what you are doing, suppose it is a sheet or it is a graph. Now what we are doing, basically it is having how many rows? 1, 2, 3, 4, 5, 6 rows. How many columns? 1, 2, 3, 4, 5, 6, 7, 8 columns. It is having 8 columns, 6 rows. Now what we are doing, we are cutting this graph paper. After cutting, what happens? One cutting, we have cutted this paper. So one cutting has 1, 2, 3, 4, 5, 6. So basically the rows will not be changed. We have cutted in this direction only. We have cutted for columns only. So how many columns? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So it is having 6 rows and 6 rows and 5 columns, and the remaining 1, 2, 3. These are the columns. What are those? These are the 3 columns. So 6 into 3. So what is our question means. Now you have to now 6 into 8 can be written as 6 into 8 can be written as 5 plus 3. 5 plus 3. Okay, now if you multiply it, what happens? 6 into 5 plus 3. This is on this side. And this is on the 6 into 5 plus 6 into 3. So if you do this, what you will get? What you will get? Basically the answer here is, what is the answer here? Here 6 into 5, 6 5s are 30 plus 6 3s are 18. The answer is 48. Here 6 8s are, that is 48. So LHS is equal to RHS. You can write this as a 6 into 5 plus 3 also. Don't worry. Okay. So what is the thing here you have to remember is, what is the distributivity of multiplication over addition is. So here 6 into 5 plus 3, the answer while doing 6 into 5 plus 3 is equal to the 6 into 5 plus 6 into 3. Even though you multiply these two and add them, you will get 48, or directly if you multiply them you will get 48. Okay, or even you can multiply, suppose assume it is not there, just it is the equation. Suppose assume this equation is like that, 6 into 5 plus 3 is there. Okay, and you have to multiply and you have to solve it. After solving, 5 plus 3 gives us what? 8. 6 into 8, that is equal to 48. Okay, in this area what you have done, you have to multiply 6 into 5 and 6 into 3. So what happened? It is also giving the 48. So in the both conditions, the answer is same. In the same way, 2 into 3 plus 5 is equal to 2 into 3 plus 2 into 5. So in this case, 2 into 5 plus 3, 8, 8 2s are 16, plus 3 2s are 16, plus 5 2s are 10. So in this case also 16. So what we can understand is 2 into 3 plus 5 can be written as 2 into 3 plus 2 into 5. Okay, distributivity, we have distributed the multiplication over addition. This property is called distributivity of multiplication or addition. This is true in the case of whole numbers. Even though if you solve this, you will get the answer. Even though if you solve this, you will get the answer. Solving this, you are getting the 48. Solving this, you're getting the same answer. So this is called the distributivity of multiplication over addition, students. That's it. The next property is identity. What is identity? Next property is identity. Basically, if you add 0 to 7, you will get 7. If you add 0 to 5, you will get 5. But if you add 7 to 7, you will get 14. So if you add any number to any number, you will get some other numbers. But whenever you add 0 to any number, you will get the same number. So we call that 0 as the additive identity. What is additive identity? Why additive identity means, if you add 0 to any number, you will getting that number only. But this is not possible with any other numbers. Why? Because if you take 1 as the additive identity, if you add 7 to 1, what happens? It will gives to 8. It does not giving you 7. So the 1 is not additive identity. So if you, sir, I will take 2 as additive identity. If you take 2 as additive identity, if you add 7 to it, you will get 9. You will not getting the same value. So these are not, 2 and 1 are not additive identities, but 0 is the additive identity. Whenever we add any number to 0, you will getting that number only. 0 plus 15 is 0. 0 plus 26 is 26. And another thing is the multiplicative identity. So suppose if you multiply 5 with 1, you will get 5. If you multiply 6 with 2, you are getting 12. So if you multiply 7 with 5, you will getting 35. if you multiply 1 with 7, you are getting 7. All these cases, what you are observing is, every time you multiply with 1, you are getting the same answer, but multiplying with other numbers will give the different answers. So multiplication of any number with gives the same number, so that why one is called multiplicative identity. Why one only multiplicative identity means, if you try to use 5 or 2 as multiplicative identity, if you multiply with other numbers, you will get different numbers, not the as it is number. So one is a multiplicative identity. So we are having both two identities. One is 0 and another one is 1. 1 is the multiplicative identity, 0 is the additive identity. That's it, students. We have completed the fourth topic also. Now what we are going to discuss, you are entering into the fifth topic. What is fifth topic? That is pattern in whole numbers. So what is the pattern in whole numbers? Okay, basically here is the game you have to you have to play. What is the game means, you have to represent every whole number with a dot. Suppose 1 means 1 is the whole number which is equals to 1, which is equals to 1 dot. Suppose 4 means which is equivalent to 4 dots, 1 2 3 4. If there are 4 dots, then it means it is the whole number is 4. So in the 3 means whole number, that is 3 dots, like that. So by every number is represented by total number of dots. And what is the thing is, we have to arrange all these dots in different shapes. You have to arrange all these dots in different shapes, but only 4 shapes are, but you have to arrange them in the only 4 shapes. What are those 4 shapes? That is, maybe in line you can arrange the dots in line, you can arrange the dots in rectangle, you can arrange the dots in triangle, you can arrange the dots in square. So only these 4 shapes are allowed. Other shapes are not allowed. So you have to take the whole numbers, and the whole numbers represents the how many dots it is having. Suppose it is 3, it is having 3 dots. Suppose it is 5, it is having 5 dots. And those dots will be arranged in any of the 4 shapes, not other than these shapes. Okay, how we can represent this line? Suppose there is a 3, suppose there is a 2, you represent it is a line. And suppose if you want to represent it as a rectangle, for rectangle what you need, so if you want to represent rectangle, take 6, 1 2 3 4 5 6 dots, which means whole number is 6. Then if you will club this, you will get a rectangle. Length and breadth are not equal. Then how you will get a triangle? If you have 3 dots, 1 dot 1 dot 1 dot, so these 3 dots will configure a triangle. And how you will get a square? Simple, if you take 4 dots, then it will give a square. So length and breadth are equal. So in this way we have to make whole numbers into different shapes. Okay, only in between these shapes. First, the number 2 is the number 2 can be represented as line, and the number 3 can be represented as also in line. Now we have to represent as rectangles. For that we have to take 6 has 6 dots, and you have to represent it in rectangle. So 1 2 3 4 5 6, it is a rectangle. Okay, and 4 you have to represent it, you have to represent in a square. For that square we have taken 4, so 4 dots, it is a square. And next, what is the next square number? That is 9. So by using 9 dots you can form another square. Then you think now I will think about what is the another square, that is of the 16. How you know means, basically 4 is contains 2 into 2 rows 2 columns, and 9 it is having 3 into 3 rows 3 columns. So what is the condition for square? Length and breadth are equal, so therefore number of columns and number of rows are equal. So 2 into 2 gives the 4, and 3 into 3 rows and 3 columns, that is the 9. 3 3s are 9 also. And next, whatever the perfect square means, that is 4 into 4 rows 4 columns, which also gives the square. 4 4s are 16. So 16 can be represented as a perfect square. So 2 is the perfect square of 4, 3 is the perfect square of 9, 4 is the perfect square of 16, 5 is the perfect square of 25. In this way you can find out the perfect squares. Okay, and how a triangle can be represented? By using 3 dots you can represent a triangle, and by using 6 dots also you can represent the triangle. Okay, And one thing is the triangle should have its two sides equal. Okay, the number of dots in the row starting from the bottom row should be like 4 3 2 and 1. While considering the triangle, the two sides have the equal dots, and coming from down to bottom to top, the number of rows will goes on decreasing. So in this way you have to find you have to fill this table. These are all the numbers. For these numbers, if line is possible with those number, you have to write as yes. If rectangle is possible with that number, you have to write as yes. If rectangle is not possible with this number, you have to write it as no. Suppose for 6 line is possible, for 6 rectangle is also possible. So yes, for 6 you can write a square 1 2 3 4 5 6. No square, only rectangle, so no. Using 6 you can write the triangle. If you try 1 2 3 4 5 6, so triangle is possible with 6. So yes, like that you have to fill for another diagrams, another numbers. That is one type of pattern. And another pattern is, now in the case of calculations, you will use this pattern. Okay, basically if you want to add 9 or 99 or 999 to any number, or subtract from any number, you can do it simply by this. Suppose 117 plus 9, if you want to add it makes some time, but simply how can you add it? Simply means you by taking 10 is equal to 10 minus 1, you can simply add it. So why? Because 117 plus 10 becomes the 127, and 127 minus 1 is simple. Subtracting 1 from number is very easy, that is 126. So 9 can be written as 10 minus 1. By returning 9 as 10 minus 1, you can easily do additions. Okay, if you want to subtract 117 minus 9, it is also very simple. Why? Because means you have to write minus 9 as minus 10 plus 1. By that you can easily subtract 10 from 117, that is 107, plus adding 1 is very easy, that is 108. So in the case of 10 minus 1, write 9 as 10 minus 1, 99 as 100 minus 1, 1000, 999 as 1000 minus 1. By substituting these values with these, you can get easy simpler equations. This is the pattern we are observing in the simplifying process. In the case of addition and subtraction, then what about the case in multiplication? In the case of multiplication, so in the case of multiplication, 9 can be written as 10 by 2. It will be very useful. Suppose 84 into 9. So finding it is very difficult, but if you write 84 into 9 as 10 minus 1, so 84 into 9 means 10 minus 1. So that what happens? 84 into 10 minus 84 into 1. So what it is? 840 minus 84. It is very simpler now. Multiplying with 10 means just adding 10. So in this way you can get easily answer. If you substitute, what is the answer for 840 minus 84? You have to do this answer. Comment me below. Tell me what is the value, what is the answer when you subtract 84 from 840. 84 from 840, what is the answer? It is a just small assignment or small homework for you. Find out what is the answer for subtracting 840 from 84. Okay. So in multiplication also you can use 10 minus for 9 and 9 for 99, 100 minus 1. So your answer, your calculations will be simplified, are very simple. Okay, then what about in the case of this? Is about the first case, about 9 9 9 90s, and the second case about 5 10 20 15 25. In these cases what you have to write? You have to write 5 as 10 by 2 and 25 as 100 by 4 and 50 as 100 by 2. Like that you can simplify your calculations. Basically if you want to find 64 into 5, it is somewhat difficult, but 64 into 10 by 2, it is very easy. Why? Because 64 into 10 means simpler, just adding 0. 640 by 2, that implies the answer is 320. So it is very simple. So in the case of 15, you can write it as 30 by 2. In the case of 25, you can write it as 50 by 2. In the case of 35, you can write it as 70 by 2. Okay. By doing in this way, you can find it answers very easy. This is the simple pattern you are observing. So that's the students, our chapter is completed. Chapter completed. Now what you have to do? Now we are going to the summary. Now we are having the summary of the whole chapter. Basically, the chapter is whole numbers. It is the second chapter. It has having 5 topics. The first topic is introduction. In the introduction, we are revising about the natural numbers. They are represented by n, and they starts from 1 and so on, 1, 2, 3, 4, and so on. Then what is the predecessor and what is the successor? Successor means the next number, or when you add 1 to any number, you will get the successor. So when you add 1 to 3, you will get the 4. 4 is the successor of 3. And what is the predecessor of 3? If you subtract 1 from any number, you will get the predecessor of that number. So by subtracting 1 from 3, you will get 2. Basically, successor is the next number, predecessor is the before number. Okay, on the number line, successor is always on the right side, predecessor is always on the next left side. Okay, this is about natural numbers. Now second topic is whole numbers. What are whole numbers? Whole numbers are represented by W, and whole numbers are nothing but 0 plus natural numbers, which means whole numbers started from 0, combination of 0 and natural numbers is the whole number. 0, 1, 2, 3, 4 and so on, all called as the whole numbers. Okay, set of whole numbers is like that. And how we will represent a whole numbers on number line? Basically, the number line must be started from 0, and for every unit distance, you have to represent the whole numbers. 0 for unit distance 1, for another unit distance 2, for another unit distance 3, and so on. This will goes on like that. So the distance between every whole number is unit distance. In this way, you are representing the whole numbers on a number line. And now how addition will be done on number line? Basically, in the case of addition, what you have to do, suppose you have to add 3 plus 1, you have to locate the position of 3 on the number line, and from that position we have to take 4 steps towards right. And in the case of subtraction, you have to locate the position of 7 on the number line, and you have to take 5 steps on the left side, towards the left side. And in this case, addition and subtraction, step length is 1 unit. Step length is 1 unit. 1 unit only. Then what about multiplication? In the multiplication, you have to start at 0. You have to start at 0. And the first term represents the how many steps you are going to take. Here 4. So 4 steps you have to take. And the second term, or the second number, represents the what is the step length. Here the step length is 3 units. So 4 into 3 means you have to start from 0 on the number line, and you have to take 4 steps, and each step is having 3 units length. So you have to start from 0, and you have to take 4 steps, and each step is having 3 units distance, 3 units distance, 3 units distance, like that. So finally, where is your landing position is, that number is the answer. So in this way, you will do multiplications on number line. That's it, students. Third topic is completed. Now fourth topic, properties of whole numbers. So what are the whole numbers? What are the properties? Is the first property is the closure property. Suppose if any two whole numbers are added, then you are getting the whole number only. So we call that whole numbers are closed under addition. This property is called closure property. Any two whole numbers are giving the result of the any two whole numbers is giving the whole number. That's why this is closure. This property is closure property. That closure property is satisfied under addition. And in the case of multiplication also, multiplication of any two whole numbers is again giving the whole number. So closure property is satisfied in multiplication also. Whole numbers are closed under multiplication. This is the first property. And we can't divide any whole number with 0. And next thing is the commutative property. What commutative property is? If you are adding 3 plus 2, 3, if you are adding 2 to 3, you are getting the 5. And if you are adding 3 to 2, you are getting the 5. So in both the cases, you are getting the same. So you can add whole numbers in any order. So changing the order does not changing the result. You can add two whole numbers in any order. So changing the order does not changing the result. So this is called as the commutative property. So addition is commutative from whole numbers. Addition is commutative from whole numbers. And in the case of multiplication also, changing the order does not changing the result. So multiplication is commutative for multiplication is commutative for whole numbers. Commutative property is satisfied under addition and multiplication. It is not satisfied in division and subtraction. Okay, and next property is the associative property. What this property tells that in this case you have grouped these two numbers first and you have solved this, and next you have added this number to for next number. But in this case you have changed the grouping. Even though you have changed the grouping, you have changed the process of grouping and adding, the result is same. The result is not changing. Even though you have changed the grouping of the numbers, the result is not changing. The result is always the whole number. So this property is called associative. This is satisfied under addition, and in the case of multiplication also, even though grouping is changed, the multiplication gives the same answer. So associativity of addition and multiplication for whole numbers, this property is also satisfied. Okay students, next is the distributivity of multiplication over addition. What does it mean? If you multiply 2 into 3 plus 5 gives the same answer, and 2 into 3 plus 2 into 5 also gives the same answer. This is called the distributivity of multiplication over addition. Here multiplication and addition both are included in the one property only. So the LHS is giving the same answer with the RHS. Okay. Next thing is the identity. 0 is the additive identity. Why? Because means if you add any number to 0, you will get that any number. And 1 is the multiplicative identity. Why? Because means if you multiply any number with 1, you will get that number only. That's it students. Now we are entering into the fifth topic, that is pattern in whole numbers. So there is some pattern in whole numbers. By seeing those patterns, we observe that 2 is the perfect square of 4, and 3 is the perfect square of 9, and 4 is the perfect square of 16. And another thing is, while doing calculations, if you observe or if you come across with 999 999, we have to replace it with 10 minus 1 in the case of addition and subtractions, and even though in the case of multiplication also, then simplification process will be very easier. And in the case when you are come across multiples of 5, 10, 25, 15 like that, we have to replace 5 with 10 by 2, 10 by 2, you have to replace 15 by 30 by 2 like that, so that your simplifications will be easier. That's it students, our chapter completed and summary also completed. If you like the session, please like our videos, share our videos. So finally, don't forget to subscribe Sreenath. Have a nice day, keep smiling, bye bye.